On this episode of Boundary Breakers, I sit down with Vinod Kettay to discuss technology company that is automating engineering drawings. If you know anything about engineering or design, you know that CAD software, which stands for computer-aided design software, is a big part of the engineering process. Vin and his team have spent the last 10 years developing a technology that leverages AI to automate the engineering drawing process, particularly manufacturing specifications process that comes from engineering drawings. It's a technical discussion, but it's near and dear to my heart. He has a fascinating company with really interesting technology, and I think you're going to enjoy it. Boundary Breakers is brought to you by Carter & Clark. Well, Vin, thank you so much again for joining us. I appreciate you taking this time out of your day to talk with us. Could you just give us just a little bit of background in terms of where you grew up, and a little bit maybe about your family and how you found your way to your first job?
Sure. I was born in India in a very big city called Chennai, which is today it's a major manufacturing hub in India. And growing up, my dad had his own manufacturing company, and I spent many of my summers working in his business. And that's where I guess really got interested in engineering and manufacturing as well. So, and my dad was also an engineer by qualification. And so when I finished high school, it seemed like the natural progression for me to go to engineering college. So I graduated with a bachelor's degree in mechanical engineering. And then I guess the itch set in to come to America. So the easiest way to come to America back in the late 80s was to come to a university and get a master's degree. So I found myself at the University of Alabama in Tuscaloosa, Roll Tide, getting my master's in industrial engineering. And once I graduated from there, like most mechanical engineers, my dream was to go work for a car company. And lo and behold, had a project with General Motors during my final year at Tuscaloosa. And GM made me an offer to join them at the assembly plant in Tarrytown, New York. So I jumped at the chance, I got in, and I started out as a manufacturing engineer, working on their minivan platform. And I started out as a manufacturing engineer in vehicle assembly, and did a lot of work in engineering design and quality control, and then moved up the ranks to become the program manager for the Pontiac Grand Prix. So I took the final generation of the Grand Prix from product to launch, while at the same time managing the operations of the Grand Prix, which was already in the market. So I launched the 2004 Grand Prix. Then I left General Motors. The itch set into, follow my father in his footsteps as an entrepreneur. And I initially started Vectra as a design services company. We worked with the tier one tooling integrators of GM, Ford, and what used to be Chrysler at that point in time. And a lot of the work we picked up from our clients was in the business of creating engineering drawings from 3D CAD models. So when you consider really any company in the manufacturing sector, any company that manufactures mechanical systems, they could be parts that go into cars, aeroplanes, missile systems, trains, and at the end of the day, even buildings are mechanical systems. So they all had to be designed in 3D CAD models by engineers. But once you have the 3D CAD models, you still need engineering drawings, or the new evolving standards, MBD, which is also known as model-based definition, which captures all the essential information related to each part and each assembly in terms of where you're going to measure each feature from, how it is going to be manufactured, what tolerances needs to be applied, all of that. So that was the bulk of the work we did. And as we continued to grow the services business, it became painfully apparent from almost day one that this was a very time consuming yet critical process, but essential process. And really, technical staff didn't want to spend their careers creating engineering drawings because it is considered lower end on the technical skill chain. Nobody wanted to do this, yet it's a necessary process. Without creating engineering drawings or MBD from 3D CAD models, you really cannot manufacture a part, you cannot manufacture an assembly, you cannot build a building or a tunnel or a bridge, whatever it may be, or an airport, whatever. So this is a critical bottleneck. It affects the manufacturing sector and the construction sector equally. Now, depending on the customer and the kind of products they design and build, it could take anywhere between 3 to 12 weeks to go from 3D CAD models to engineering drawings, which are ready to be released for manufacturing. And that is because there's a heavy reliance on human technical labor, and there's also a lot of truly non-value added QC. They are checkers that check every single 3D CAD model, and then they check the engineering drawings to make sure there are no errors, they are accurate. All the information that is required to manufacture the parts are in fact encapsulated in the drawings. And the checkers mark up the drawings and send it back to the design teams to fix all those errors. And when the design team fixes all those errors, they have to send the CAD files back to the QC people, and they have to check it one more time to ensure that everything they marked up as an error was in fact rectified by the design team. Only then do they get to release them for manufacturing or construction. In spite of all this heavy reliance on QC, and the focus is there, but yet the QC is being done by human beings and they are not infallible. And these QC people, when they are launching a new product, are typically working 12 hours a day, 7 days a week, and they miss stuff. And they are constantly under the gun to get the drawings released so that they can start manufacturing them to meet the shipping deadlines or the installation deadlines, whatever. So there's constant pressure during product launch, and especially in a manufacturing company like GM that I used to work, there is typically a prototype level design, then there's an improved prototype, and then there's a further refined prototype design. They have to create 3D CAD models and engineering drawings or MBD at each prototype design level. And finally, when they get to production level design, they have to do production design as well. And on top of it, they have to assign the correct tolerances to every feature in every part that needs to be controlled during manufacturing. And when you stack up all the tolerances at various parts and features and look at the entire assembly as a whole, you have to make sure that the tolerances do not exceed what is important from a customer aesthetic perspective or from a product functional perspective. So that tolerance stack simulation and analysis is also a critical piece of the engineering design process. And that is something we are also continuing to automate, and we should have that automation as well completed by Q1. And once we do that, that would be a complete game changer for the manufacturing sector.
Yeah. No, that's fantastic. And I appreciate that excellent overview. So I want to, for the broader audience that may not be as technically savvy or might not be in the manufacturing space, to provide sort of an analogy, maybe one way to think about it is if you were going to build a house or do some type of, addition or maybe build a shed or something in your yard. Sort of the fun part, or the part you got to figure out first is, and I'm relating it to everything that you just said. You would build a 3D model. Hey, look, this is the shed we're going to put on the other side of the driveway. Isn't it pretty? Well, no, we want it to look a little bit more classic. You sort of design it that way. That's the fun part. But at some point, you got to take that and you got to build the whole construction set, right? You got to build the electrical schematics. Is it going to have HVAC? What about the roofing? What size are the shingles? What type are the shingles? What specifications do they need to be installed to? All the way down to every detail, the flooring, etc. If you're in your case, if you're manufacturing a part that will go in a vehicle, and I'm dumbing it down, I realize, but it's a similar process, right? Is everyone agree? The fun part is sort of the visual design. Everyone agrees that's the 3D model. That's fantastic. But then you've actually got to get into the devil's in the details, and you got to create, just like you had to do for that shed. You got to create all the various engineering specifications that, like you said, show the tolerances, the details, how far apart the teeth on that particular piece of metal will be, how it's manufactured, etc.
That's exactly right.
So that's a fair sort of layperson explanation or perspective on sort of the bigger picture of what we're talking about, right?
I think that's pretty accurate. And I would just elaborate a little more to say that engineers are focused on creating the 3D CAD models. That is where their creative energies they like to dedicate to creating a 3D CAD model that meets all the functional requirements of the system. It's not just that one part. That part usually is mated with other parts, and that whole system has a certain function. And the engineering analysis and the focus is on creating 3D CAD models that represent all the functional requirements, like if this part is going to have to withstand a load of, say, 1,000 newtons in this direction and some dynamic loads in this direction. So the 3D model, when they complete it, has to be able to represent a part which can withstand all those requirements. But what the 3D model does not contain is how are you going to actually manufacture the part in the world of manufacturing with the machines you have, with the equipment that you have in a factory or a plant. How are you going to manufacture it? How many different processes are you going to use to manufacture a single part? And how do you control those tolerances that are applied, and those tolerances that you apply on various features on a part drawing are very critical, because if you don't apply the right tolerances, you're going to have a part where it's mating with another part and the two parts do not fit together. You just cannot build the assembly. Or even sometimes if you're able to build them, as you operate the part over and over again in the real world, you'll find that because the tolerancing wasn't adequate, the part fails in operation or it doesn't perform its intended function correctly. So that's a problem. So the aspect of calling out the tolerances correctly in a product design is very critical. And that is what we are currently automating using AI.
Yeah. And that's fascinating. And we were speaking briefly before in my world, or in our world, you've got the planning stages of a real estate development, right? Whether it's in our case, it's typically residential subdivisions where they build 3D models, and I relate to what you're saying with regard to the specificity of the tolerances. In our world, if you don't have the tolerances correct, you're going to build a house or build a piece of property or building on somebody else's lot or somebody else's property, or over a setback line, for example. And so it's interesting to think about that in different contexts, right? If it's in a manufacturing context, the part doesn't mate with another part or doesn't function appropriately. But point well said and well taken, that this isn't sort of just here's sort of a picture-ish. The proportion, the scale, the down to I'm sure in your case, down to the several hundred thousandths of a centimeter, or even more accurate than that. So it's fair to say that that's the 3D, the initial 3D design, which is also done by engineers, but you mentioned that's what engineers want to do. That's the creative part. That's where you can sort of express your creativity and your talent and differentiate. But then the hard part, if you will, is going from that to, okay, now specify every single little instruction for how we're actually going to create this thing that was designed, right?
So I would say the hard part is creating the 3D CAD model. I don't want to diminish that.
No.
The aspect of creating engineering drawings is not the harder part, but it is the grunt work.
Right.
It is not right. It's not creative. It's not exciting. But it's not trivial either. You can't just put somebody on the job and expect them to do the job correctly. And companies tend to hire people straight out of college or vocational school and put them on this drafting process, which is the aspect of creating engineering drawings. And anybody who is any good wants to move out of that position and move into 3D modeling or doing engineering analysis like structural analysis, which is a lot more sophisticated work. So the problem that companies face is everybody's any good is moving up to something else. And you are constantly filling this engineering drawing creation process with newbies, and they're constantly in learning curve. Once they finish their learning curve, they're out doing something more value added for their company.
Gotcha. Yeah. So
and
it's not
in the U.S. defense sector, there is a particularly painful bottleneck because they cannot send their CAD files to countries like India, who have a lot of technical labor, to get the drawings done there. There are ITAR regulations which prevent these companies from sharing any of their CAD files with anyone outside the United States. And these companies have to rely on US citizens doing this kind of work within their facilities. And it's obviously hard for them to find these people and retain them. So they're usually hiring these people. Then if there is a lull in the project workload, they end up having to retrench some or many of them. And then when they have another huge project coming in, they have to bring in typically contract workers. And to pay these contract houses, there's a premium they pay for these contract houses to supply the manpower. And then again, the new people they bring in, they're not familiar with this company's drafting or MBD standards. So there's a learning curve there, and they make mistakes when they start doing work for a specific defense contractor or manufacturer. And the burden falls on the QC guys to find all those errors. So it's a process that hasn't dramatically improved over the years. Of course, there was a huge sea change and quality improvement when the world went away from paper drawings on paper and T-squares and pencils and erasers, went to CAD modeling. There was a massive upheaval and improvement in the whole process. Now we are bringing in the next generation of major improvement by automating this, I would say, uncreative process.
Yeah.
And freeing up companies to deploy their people into tasks and in real engineering so that they can optimize their design. And when they optimize the design, they can design it in such a way when they actually manufacture it, the manufacturing cost is actually lower. So in the case of a house or a building like a school or a stadium, architectural design engineers and structural engineers can focus their energies and spend more time on optimizing the design so that when they actually build a stadium or a hospital, you lower the build costs. And reducing several weeks of their drawing creation process down to a few hours gives them the ability to spend more time and utilize more resources and actually lowering the cost and making the structure more sound or more appealing and so on. It just gives you time to do the more creative stuff, so that the grunt work is compressed from weeks to a few hours.
Yeah. Then you're speaking my language. We do about 15,000 property surveys a month. And so we have a whole army of quality. We have a three-stage QC process. And so the majority of our time spent QCing the surveys that are generated in CAD for accuracy. So you were at GM and you recognized the need to have a design services company to support manufacturing companies. You started Vectra, and that has, if I'm not mistaken, that's evolved from a design services company to more of a technology company, right?
Technology product, software product, technology, and you could call us a B2B software as a service company now. And you're a niche product. And it's interesting that you mentioned that you have a three-stage QC process. And that is one thing I didn't touch upon in our product portfolio. Now, when we first launched our platform to auto-generate engineering drawings, we knew this would likely happen. And the whole issue was there were errors in the 3D CAD models that the designers created. And our software was using the 3D CAD models as the input to our platform to auto-generate drawings. And there were errors in the 3D CAD models. For example, if you had two parts mating with each other, and there was a hole in this part and a hole in this part, and if those two holes were not aligned correctly, if the hole centers were off by a millimeter or so, when you actually built those parts and try to put a bolt going through those parts, they would not fit with each other. There were errors like this that also affected the drawing output. And because of that, we introduced a product which is now called Model QC, which enables design engineers to create the 3D CAD model designs and also the assemblies. And then rather than waiting for a QC person downstream to review the accuracy of the 3D CAD models after the drawings were being generated, which was their traditional process, now the engineer who does the design in the 3D, he has the ability to run our model QC on his workstation. It rapidly and reliably identifies errors in the 3D CAD models like hole misalignment and hole to shaft alignment. And if there were unintended gaps between parts, it would identify all of those and prompt the engineer to fix those errors in the CAD models. So when he fixes all the errors, then we have a clean 3D CAD model assembly, which serves as the input to our auto drawing generation or auto MBD generation platform. So that enabled our designers to dramatically reduce the QC effort. And also, the QC guys don't find anything wrong in the models or the drawings over the period of time. They're also able to get through their QC work much faster and get to release much faster. So the aspect about QC that he brought up is actually a very integral part of us being able to reduce the lead time from 4 to 12 weeks down to a few hours.
Wow. Well, so tell us a little bit about, you mentioned AI and that the technology utilizes or leverages AI. Tell us, I mean, I can't imagine the time and the effort that would go into building software that would be able to create the engineering drawings from 3D design. Tell us about the AI portion and what is sort of behind the software. What is it? Is it some type of generative AI model that you guys have trained and it recognizes likely errors based on other drawings that are, I mean, how does it, tell us more about the software.
Sure. As far as the AI component of our tech stack, the model QC or the QC modules, they have no AI component. They're all strictly engineering rules and proprietary algorithms that we've deployed. Where AI comes into play is in actually generating engineering drawings and figuring out what datums should be selected for a given part, what features need to be dimensioned, and what tolerancing is to be applied to each feature in the drawing, in the part actually. So, and typically AI is not very good at giving you very precise answers. AI will typically deliver, for example, give you an example that everybody's familiar with. If you want to predict the high temperature for tomorrow, you have a whole thousands of factors that play into predicting tomorrow's high temperature. But a weatherman can only predict tomorrow's temperature with, say, a 90 to 95% confidence that it's going to be 68 degrees tomorrow. That 90 to 95% confidence does not cut it for what we do. We can't tell our customers, hey, we are going to generate this drawing. This drawing is going to have 150 drawing symbols on it. And we're 90% sure that each of them is going to be correct. That adds no value to the customer because then they had to go check everything and say, was this correct? Was this correct? Was this measured from the correct datum? Was this tolerance done correctly? That is useless to a customer. So we use machine learning at the core of our platform. And machine learning by itself, again, doesn't guarantee you very precise on the spot answers. It will, but so we have actually built a confluence of machine learning and some very proprietary algorithms that we have developed over a 10-year period and deployed that into our platform. And that is how it's able to produce very reliable, precise dimensions and symbols on the drawing that a customer can absolutely rely on. So this, and what is very complex about this process is where we are able to extract certain types of data from a 3D CAD model. There are roughly about 30 parameters that we extract from a 3D CAD model. But based on our history of developing algorithms to automate this whole process, we realized there were over 300 hyperparameters that we needed to compute from the 30 parameters we were able to extract from the 3D CAD models themselves. And it is these 300 hyperparameters that we had to feed into our machine learning system. And that's how it's able to produce some very precise, repeatable responses. So if a company that's coming in and trying to compete with us today, they can't just go extract those 30 different parameters from 3D CAD model and feed into machine learning and hope to get the answers. They're going to get awfully terrible answers. But our 10 years of algorithmic development in the background, we know what for a hyperparameters to compute from the 30 input parameters from the CAD models. And that's how we feed it into our machine learning system. And that's how it's able to produce very correct responses for every single element in a drawing or an MBD.
That's fascinating. So if I'm understanding correctly, there are 30 parameters or data points that sort of come standard in the 3D CAD model, but you guys have figured out how to extract an additional 300 data points?
Correct. They have to be computed. Yeah. So for example, if you came in out of the blue and you were going to predict the, write a AI program to predict the temperature, and if you did not know that the tilt of the Earth's axis relative to the sun and how it changes from season to season, if you did not know all that already as a scientist, and you're not able to, you're not measuring that, no matter what you do in your AI model, you're going to get crazy responses. So it is these 300 parameters that we were able to calculate from the basic 30 parameters, that's what gives us the ability to do the predictions that we can today.
Gotcha. I love it. Well, so on the business side of things, as you guys started to transition from less of a consulting business to more of a software as a service company, how difficult was that? And you know, in terms of the like adoption by the customers and the sales process, I mean, did you just walk into manufacturers and they say, "Oh my gosh, I love it. How about I'll pay you whatever you want"? I mean, or tell us about that, the entrepreneurial experience of it.
Virtually every company is excited about reducing the lead time going from 3D CAD models to engineering drawings and reducing their reliance on technical staff. But the biggest challenge we have is customers see our demos, they are excited by it, but they also think it's too good to be true. They, they just can't believe it. And we show them demos of drawings we've generated on various types of parts. And they're thinking, oh, the parts I design in my company don't look exactly like what you're showing me. So there's this whole fear factor. And the way we get over that is we do a proof of capability or a free configuration for certain clients that we approve that we want to bring on in the earlier stages. So we do a no cost configuration for them. And that configuration process currently takes about 3 months for our team to receive 3D CAD models and engineering drawings or MBD, which the client has designed in the past and on various projects. Those form the inputs to train our machine learning system and our algorithms. So that whole process, we use supervised machine learning and a bunch of other techniques. And at the end of 3 months, then we are able to start generating drawings which are specific to the kind of parts that customer designs. And also those drawings or MBD will be in compliance with that particular manufacturer's drafting or MBD standards. When they go through that, once they see the drawings being generated for their own parts, that's when they say, wow, this is real. And that's after that is when they become a paying customer. So Vectra assumes the burden of doing the initial configuration, which is a significant effort. That's why we are focused on the larger companies, because the larger companies, there is a heavier workload, obviously. And when we go to the OEMs, they're also in a position, once we prove it out to them successfully, they're able to point us in the direction of their suppliers and say, hey, these are suppliers of ours that could really benefit from speeding up their design lead time to support our product launches in a much better fashion. So that is how we proved out the technology with some smaller companies. They're not small, but they are
Right.
smaller than
Relatively.
the multi-billion-dollar behemoths that are our true target market. So this is where now, and we are finding also that in the architecture and engineering construction world, we tend to deal with smaller companies. And then we're not talking about companies with 50 billion in revenue. We're talking about companies with 2 to 5 billion in revenue. And they crank out a huge number of drawings, which even as a mechanical engineer, I couldn't fathom till I actually talk to them and how much work is going on at the civil drafting end of the world. And for us, that's a low hanging fruit. And the civil drafting work is actually technically much simpler than what we have pulled off in the manufacturing world. Because when you're designing a building, you don't have complex geometries like you would see on a part that goes into a car.
Yeah.
It's typically a lot of it is structural beams and columns and concrete and some holes. Nothing terribly complex. So we actually having to turn off a lot of the functions in our base software so that we can do the architectural drawing generation with less computational effort.
Gotcha.
Comes down to turning on a lot of our functionality than adding new functionality to it.
Yeah, that's interesting. And so, in terms of the input, whether it's now or looking into the future, I assume it's limited to. I mean, does your software requires a 3D CAD input in order to generate the drawings on the back end? Correct.
Correct. And our software plugs into various CAD platforms that are used in industry. So in the manufacturing world, all the biggest companies use either NX or they use CATIA. Um, they also use SolidWorks and AutoCAD and so on. And all of these major CAD platforms have what they call APIs, application programming interfaces, with we are able to leverage those to extract the necessary information from the 3D CAD models. And also at the end of the process, we are able to auto-generate the drawings in the native CAD format. So if the customer designs their 3D models in NX, they want their drawings in the native NX format. They're not going to go to some neutral format. And then in the construction world, the most commonly used platforms are Revit. Then you have Plant 3D, you have Civil 3D, and you have MicroStation and Open Building and so on. And we have plugins for several of these, and we're continuing to build out more plugins for all these various CAD platforms. Because if we didn't plug into these CAD platforms, our product would be a no starter. We absolutely have to plug into the platforms that companies are already using. No company wants to switch from one CAD platform to another. It's a huge expense. It's a huge training thing. It's a huge mess. So we just have to adapt to what each customer is doing, and that makes it easiest for quick adoption.
Yeah, that's great. Well, like I mentioned before we got started, we will we'll put up a demo, a short demo so the audience can see and really visualize what we're talking about. If you have one that you can share with us,
Absolutely.
So that I know it can be very sort of nuanced what we're talking about if somebody in the audience wasn't familiar with engineering drawings or CAD drawings really at all. So I think that will help bring it to life a little bit. And of course, we'll make sure to follow up to get that, to get a demo or whatever asset you think might be helpful in visualizing. So how about tell us about your team? I mean, I'm sure you have a lot of other folks that have helped or are helping build this business. What has that experience been like, finding people to help execute or build your vision?
So we've had the top managers in the company with us for 10 plus years. So we have a requirements analysis team, and they're the first point of contact with the customer after the sale has been done. So they receive the 3D CAD models and reference drawings from customers, and they take that information and translate it into terms or requirements that the software development people can understand. And in the software part of our development part of our business, there are essentially two sides to it. One is the CAD solutions team, and this is a team that extracts information using the CAD APIs from each CAD platform and puts the data in a format that the algorithm and the machine learning team can actually use, so that all the algorithms and machine learning actually run on AWS, which gives us infinite scalability. Our process and our technology is extremely compute intensive. So if we try to generate the drawings on the CAD workstation and do all the uh, earlier computations on the CAD workstation, it could tie up a CAD workstation for a week or even two. And these CAD workstations are expensive. These CAD licenses are expensive. They cost $25,000 to $30,000 a license. We're talking about NX and CATIA, and nobody wants to tie up their CAD license for so long. So what we're doing is we are extracting metadata from the 3D CAD models. We encrypt that data all in an automated process, send that to AWS, and that's on AWS. We determine the complexity of the design, and then we decide whether we're going to spin up 10 servers or 100 servers on AWS to do parallel processing of the various elements of that drawing generation. And at that end of that process, it generates an instruction set that is sent back to the CAD workstation, again, after encryption. And on the CAD workstation, it engages the APIs of that native CAD platform to generate the drawings right there in that native CAD format. So we've taken this very compute intensive process, put it on AWS, and that's how we're able to squeeze everything down into a few hours.
Wow. So I guess with an API, is it fair to say that there could be an engineer at a design engineer at a manufacturing entity that completes the 3D design of let's say some type of auto part, and assuming that they're obviously they have to have already been a customer and gotten the setup and everything is connected. Are you saying they could essentially submit that 3D drawing sort of over to you guys for you guys to create all the engineering drawings, and it'll be delivered right there to their CAD workstation within a
Exactly.
matter of
And
hours?
right now, it's like an overnight process. So when the engineer is done with his design work for the day, there's an entire assembly that he wants to have drawings or MBD generated for that. He Within a minute, he sets up an automated run of Auto 2D or Auto MBD. Those are two platforms. And then he can go home for the night. And everything is happening unattended in the background. And by the time he comes back to work in the morning, he will have drawings that he can look at.
God.
Or the QC team can take a look at those drawings.
So something that used to take 3 to 12 weeks is now electronically submitted and available on right there on the workstation the next morning.
Absolutely, yeah. And there are customers who now want this. They don't want to wait overnight. They want to do this even during the day, because the guy could have some designs ready to go or 3D models ready to go for drawing generation at 10 a.m. They don't want to wait till the next day. They want to, for that, we can do an alternative setup where they have a separate server that we set up within their IT infrastructure, and that continues to work while the designers are working on other designs.
Wow. Wow. Incredible. Incredible. So where is the business in terms of sort of the maturity, life cycle? Are you guys, do you have a core group of customers that are where you're revenue positive and you're trying to add more? Are you closer to, closer to the infancy phase where you're trying to get the word out about this? Where on the business life cycle are you guys at the moment?
We are still at what we would call an early stage. We have 3 key customers, and we're continuing to add. And like I mentioned earlier, we focused on customers with smaller workloads. Now we are working with large companies where they have multi-million dollars potential in annual contract value. And so we are, in terms of fundraising, we are at a pre-Series A stage, and
Okay.
we've raised over $4 million over the past few years, and we are expecting a couple of big contracts in Q1, and based on that, we plan to raise a Series A of 20 million in Q2, and that will help us significantly grow the company and add, and we're probably not going to be, at least in the next 2 years, we're not going to be the kind of company to bring on hundreds of clients. We're going to have maybe a dozen, maybe 2 dozen clients, but with very large contract values. And right now, what is significant factor that slows down our sales process and the time to revenue is the fact that we have to configure our platform for each new client, because every client has their own standards. We see that as it's kind of an essential step right now. Just like when somebody buys SAP, they don't expect it
Yeah.
to work out of the box. It's got to be configured for their business workflow. Our software has
Yep.
to be configured for the customer's CAD workflow.
Yep.
But we really want to use AI to get our software to the point where it can configure itself using unsupervised machine learning, going away from the supervised machine learning process that we employ today. And to us, that's truly our holy grail. Once we get to the point where our software can configure itself, we our vision is to have a sandbox in the cloud where we have NX and CATIA licenses and SolidWorks and Revit and so on. And customers can upload their reference CAD files to our sandbox in the cloud. And then maybe within 2-3 days, it configures itself. And then it's ready to start spreading out drawings which are compliant with that customer's drafting standards or MBD standards. To us, that's our holy grail. And once we get there, we really want to package our product with the major CAD platform owners like Siemens, who owns NX, Dassault, who owns CATIA, Autodesk, and PTC, Creo. Package with them and then have them sell our platform as an optional add-on to their global clients. And even then, I think in initial stages, we would be focused on supporting their large clients because that's where the volume and the real profits are. But eventually, say over the next 10 years, I think the product will evolve where even a small company can just upload their files and have it auto-configured, and then it starts, even small companies can start using it. But obviously, right now, the focus are the big companies, just like when CAD started making inroads in the 80s, they were focused on the big companies. They were focusing on the GMs and the Boeings of the world. And that's kind of where we proved out our platform with smaller companies. And now we are showcasing that to the really large companies who are our true target market.
Yeah, that's great. And you guys recently won an award for the software, correct?
I believe so, yeah.
Do you want to talk about that?
Well, it's not of much significance really, because ultimately our success is going to be dictated by when customers see the value of our software for themselves. So that's truly what we are focused on.
Yeah, fair enough. And I appreciate the humility, but to be fair, from the audience perspective, there's a lot of entities out there that are building and introducing new software, and to catch the attention of any group that is sort of identifying which ones are and are not special, or which ones have are making a significant contribution, or cutting out 3 to 12 weeks of what is now manual labor. I think that there's something to be said for that.
And in many ways, we are kind of competing for attention with all those other companies that are just hyping up AI, and they're not even really using AI. It's just like, oh, what you throw this word AI around, then it seems like companies want to talk to you, and they're talking to so many companies, and they're kind of forgetting what's going to really give them value, with very little effort on their part. And for some early adopters, we are going to offer no cost configuration. So there's really no risk to those clients to give us the files for us to configure it, prove to them that it's going to work for their particular designs.
Yeah. So who is your absolute, do you have like a particular client or industry or type of company that would be your ideal client? Like, gosh, if we could, we would make the biggest difference if we were able to get, this industry or this particular client, or is it sort of more agnostic than that?
It is truly agnostic, but customers generally don't understand the agnostic part of it. They only want to know, hey, is it going to work for me? So what our focus is in the short term, and what you bring up is very valid, is we want to land a marquee client in the automotive sector. It could be a major automotive OEM like GM or Ford or Toyota. One in the aerospace and defense sector, it could be RTX, or it could be Lockheed, or one big nameplate in that sector and one big nameplate in the construction sector. Once we have that, then all the dominoes will start to fall.
Right. Right. I think that's I like that strategy. And from what I can tell, from what I understand, it's almost a no brainer. In fact, it's so much of a no brainer, provides so much value. Like you said, it's almost hard to believe to imagine uh, having engineer design something in a CAD platform, and then almost as easily as you do spell check and word processing to say, okay, now create my engineering drawings. That's very difficult to sort of comprehend given where things are today. But very exciting. I mean, that kudos to you guys for figuring that out. I cannot imagine, you mentioned the amount of compute, the amount of just the overwhelming number of calculations required. I mean, I can't imagine what the labor and effort that would have gone into writing the code for the software that would actually, generate all those computations. So
Yeah, and
that's
our architecture has changed dramatically since we first started out with this. So much we learned initially, we hard coded everything to be compliant with GM tooling standards. And then once we proved that out for ourselves, then we said, oh, how are we going to make this configurable so that we can handle Daimler standards, Stellantis standards, and then how do we take this? Where we started out was fabricated systems, which go through a certain series of manufacturing processes. Then we had to figure out how do we make this work for parts which are cast and machined, like an engine block of a car, cast and machine parts. Then how do we make this work with plastic components? They have different geometries we have to deal with, different draft angles that come into play, different tolerances. And then you have formed sheet metal parts. So most of the body structure that you see on a car, that's all formed sheet metal parts. So we had to figure out, okay, how are we going to make all of these things work? And how do we make it easily configurable for each new customer who's going to have different drawing standards, different MBD standards? And the way these customers structure their 3D CAD models is different. Even 10 customers using NX as their CAD platform would have different ways that they structure the 3D CAD models. And our software has to be able to read those differences and still be able to output the information that the ML and the algorithm development team needs to process all of that, process it through our ML system, process it through our algorithms, and provide drawings or MBD which are compliant with that customer's drafting and MBD standards. So that is why we kind of stayed on a relatively flat, no growth state for about 3 to 4 years. And only in the last few months, we've started talking to potential new customers, and we hope to sign some key contracts in Q1 and raise our Series A in Q2.
Gosh, well, amazing. That just gave me a headache thinking about everything that you guys had to account for. So I got two more questions. Again, I appreciate the time. I'm curious, just your general thoughts. With AI, and the recent sort of explosion of AI that everyone is talking about, and how quickly it's able to sort of disrupt. What do you envision the impact of AI being just on the engineering industry as a whole over the next 10 to 20 years?
I think the most dramatic impact would be in the actual engineering the product and taking it through paces in terms of simulating the loads and thermal stresses on the computer, which already exist, but I think AI will take it to a new level where you can do it to a higher degree of fidelity with less time. But I think it's going to take some time for that to really mature because AI by itself is not going to replace physics. You still have to do physics analysis of a mechanical system. There are established formulas, and finite element analysis that you have to do. And I don't think AI is going to replace any of that. It may be able to uh, complement some of those analysis. And I think there's going to be a sea change in how manufacturing is. You're able to gain insights into your manufacturing processes and focus more on predictive maintenance using AI. I think those are going to be very dramatic. And in terms of even your logistics and supply chain, I think there is no aspect of our lives that's not going to be touched by AI. And I personally think and hope in 5 years' time, we can all afford a robot we can buy for 50,000 bucks that we can have at home to do the laundry, do the dishes, maybe give you a massage even, So,
Yeah.
but that's,
Yeah. It's amazing. It's hard to imagine. And I think most people, they don't work with it every day, or maybe not as, technologically savvy. There's always this sort of gap or question in people's mind of, well, okay, you got the big bad AI is coming, and I just keep hearing it's going to disrupt and it's going to change. But what does that actually look like? What does that actually mean? And so I appreciate the insight there. That's really that was a great
so
answer,
those
and
are the
very,
positive impacts that we should look forward to. But there's obviously the threats that it brings, and a lot of people have been speculating about it. And I think it's real. I think I forget the name, but the person who's considered the father of AI, he left his job at Google, and now he's talking about all the threats that AI can bring to humanity as a whole. And we can't ignore that. I don't know how we mitigate it, but it's time to start looking at those.
yeah,
And
I
those are
agree.
much
I agree.
bigger global issues than the very little focused process that we have automated.
Yeah, for sure, for sure, for sure. But very insightful. I mean, I appreciate your opinion. So last question. It's a little cliche, so forgive me, but it often solicits pretty remarkable answers. If you had to go back, or if you were able to go back and talk to the Vin that was just leaving GM to start your business, based on sort of everything you've been through and everything that you've learned, and you had a minute to talk to that Vin, what would you tell? What would you tell that version of yourself?
Oh, that's a tough one. With the you're saying with the knowledge of hindsight,
Right.
what would I tell?
Yeah. You now you get to visit your younger self when you were first starting Vectra, and you get a minute or two to give some insider advice or thoughts. What do you tell them?
I would have spent more time finding the right co-founders. So I am a sole founder. I have a lot of investors who have backed the enterprise, friends, family, and angel investors. But I think we could have done things faster if I had co-founders with somebody with a very deep knowledge of computer science and somebody with very specific types of design experience in the 3D world, that kind of stuff. So this is a team that I put together. I hired people, but I also know so many teams that have fallen apart because the co-founders did not gel with each other. So in a way, I do consider myself fortunate that I don't have to deal with that. I just you probably don't hear about those companies because they never made it big, and you're not going to read about them in Forbes or Fortune or Inc.
Right.
magazine, right? So I don't know. So and also it can take years sometimes to go find the right co-founders, and sometimes you never find those right co-founders who have the ability to take risks to the level that I did. But when I say I call it a risk, but I knew it was always a sure shot because when I set out on this journey, I knew that it could be done. I did underestimate the amount of work it would take to get this launched properly, and where it's completely domain agnostic, CAD platform agnostic. I completely underestimated that. Um, I don't know how I could have foreseen that. I mean, I think that's mistake that a lot of founders make is they underestimate the quantum of work ahead of them. And You heard Jensen Wang talking about that, about NVIDIA, and he says it's a typical mistake that people make, but a lot of successful entrepreneurs also say the most important thing is grit. So
Yep.
if you know you're working on a product or service that has value in industry, you stick with it. As long as you're making gains towards making it close to flawless.
Right.
Our value proposition is very strong. I wish the adoption had been faster, but I still see the company scaling to great heights, and it's a huge market. And so there is obviously going to be competition in the future, in the near future. We have to be prepared for that. But again, it's not like Microsoft Windows, where once you install it on all PCs in the world, there's almost no place for anybody else. Like Apple had to come up with their own hardware to run Mac or iOS or whatever. This is not like that. You're going to have probably 5 players in the next 10 years, and we expect to be the market leader as we go forward.
Yeah, I love it. I love it. And I love the reference to grit. And, almost every entrepreneur that I have spoken with it admits to, I think it's impossible, and I'm an entrepreneur myself, I think it's impossible to comprehend the actual amount of time and effort and energy and devotion and dedication that is required to get most companies, to realize the dream, right? To realize the vision, to really get it there. And a lot of people, have said to me, had I really truly known really what this was going to take, I don't know if I would have done it, but I'm glad I did, and appreciate it and everything. But it's a common thread that I hear often is it's a lot more work, a lot more time, and a lot more resources are required than at the outset it appears. So,
yeah, and there are 2 memes that I think are particularly meaningful. One is where they show a guy jumping off a cliff. So they say like entrepreneur is like you jump off a cliff and you build a parachute on the way down, and hope you build the parachute before you hit the ground. The other thing is that really sticks with me, and I share this with my team, is there's this team of people, they're digging a tunnel underground, and they give up when they get here, and there is a whole stack of diamonds like 2 feet from where they stopped. They just gave up because it was not yielding any results.
Yeah, so keep digging, right?
Keep digging. As long as you know, but you have to be realistic and understand whether there's a true market for what you're building. You got to be sure about that.
Yeah.
Otherwise, it's a pointless exercise.
Absolutely. Absolutely. Well, Vin, I sincerely appreciate your time this afternoon. I'm glad we have a chance to dig into the amazing the software solution that you guys have created. And I look forward to watching it disrupt the engineering industry as it becomes adopted by more businesses.
Thank you, Brandon. It was really interesting chatting with you.
Don't forget, everybody, you can find Boundary Breakers in a lot of places. You can watch our episodes on the Boundary Breakers YouTube channel, or you can listen to each podcast on Spotify, Apple Podcasts, or any of the other major podcasting platforms. Thanks for listening.